Okay, just a hint. If I start here and use the original displacement, that means that what? My x value is here, so I've got to displace over to about here to get my new x value, and the x value at this point will have to be double the x value at this point. Well, here's an x value for this point. About here is an x value for the doubled point. Unfortunately, my new point is going to lie inside my labeling here, but it's going to be about here. And if I move in the opposite direction, I mean, my arrow is still in the same direction, but if I move to the point from which I would have arrived here, then my x value has to be cut in half. So that's going to put it about here. Now, we're going to keep having the x values every time we move to the left, keep doubling them every time we move to the right. And I kind of think that's going to lead to a graph that might look something like this. So there's one of your graphs. What if I start from this point and move in the opposite direction? So I'm going to use, I used the, I'm going to change the color of chalk there too. Okay. Don't like to keep doing this on screen, but doesn't hurt for you to see me thinking a little bit on those days when that actually happens. Okay, so I'm going to use a negative, a purple arrow for the displacement in the opposite direction. So what would happen, and I'm not going to start from this point or this point, I'm going to let you work on that, but what would happen if I started from this point and moved in the opposite direction? Okay, so let's say that I had this point here, which gives you the same x value as it does on the graph that we actually did, and I move this way. Okay, well, the displacement is in this direction, but that x has to double. So the x value here is going to go from this up to about double, so that's going to give us a point maybe here. Now if I do the purple displacement here, it's going to take me to the same x value I had here, but the value is going to have to be halved. So that's going to give us a point probably about here. Okay, and now we see that the graph is going to go through this point, and this point, and then it's going to continue going closer to the x-axis. So the graph is going to maybe look like this. Okay, well, that's a couple of hints. Proceed. I'll let you think about what to do with this point below the x-axis, but if we double its distance from the x-axis, let me just say as a hint, it's not going to move to this side. It's not going to become twice as far away up here. It's going to become twice as far away down here. Okay, so we move, it's going to become twice as great, twice as far from the x-axis. The y value will double.